Good morning. You are going to like this lesson because it is going to remind you of some things you did last year, and we're done with graphing, which should make everyone quite happy, myself included. So let's look at 11.2 part 1 when we're going to talk about simplifying radical expressions. Now, you're going to remember having done this last year in pre-algebra, and it's going to feel, I think, much easier to you this year. So, the number one thing to remember is when you have a radical expression, you want to get it into its simplest form. And what that means is you want that radical to not have any more squares in it. So, give you an example, the square root of 32. The square root of 32, if you look at all its factors, contains 4, right, times 4, which is 16, times 2. Okay, so it contains 4 squared, or 16, right, times 2. And because it contains 4 squared, or 16, you can also express it that way, it means that it's not fully simplified because the radical contains a perfect square. So to bring it to its simplest form, you have to separate this radical into 2 sections, square root of 16 times the square root of 2. And now you're able to separate out that square root of 16 now becomes 4. But this, you can't get a perfect square of 2, so we're just going to leave that as square root of 2. And so the simplified form of the square root of 32 is 4 square root of 32. Now, I started with that because I want to backtrack and talk about things we've talked about before, which is what gives me the right to do this? Why can I take 2 things multiplied inside a radical, a times b, and what lets me separate that into the square root of a times the square root of b? Well, there is a property called the product of radicals. So the property of radicals. And this says that the square root of a product equals the product of the square roots of the factors. So the square root of the product equals the product of the square roots of the factors. And that's just exactly what we said. So if I have the square root of, as I had here, 16 times 2, it means I can separate this into the square root of 16 times the square root of 2. If I have the square root of 4x, it means I can separate it into the square root of 4 times the square root of x. Here we found this gave me 4 square root of 2. Here we would find that since the square root of 4 is 2, I would end up with 2, and this isn't going to divide any further, or I can't take this even square root of x, so I'm just going to leave that as square root of x. Okay, so let's try another one. Let us try the square root of 9x cubed. Now that's what I did at the top was part A of example 1, and I put my product property of radicals in the middle. And now I'm going to do part B. So we'll do this other example, square root of 9x cubed. Well, I can separate this into a couple different factors, right? I can separate this into the square root of 9 times, and x cubed is x squared times x. which means I can get 3 radicals out of this. The square root of 9 times the square root of x squared times the square root of x. The square root of 9 is 3. The square root of x squared is x. And the square root of x can't be simplified any further, so it stays as is. So my answer is going to be 3x square root of x. I want you to, right now, I want you to try Guided Practice 1, page 719. Pause this video and try it. And I'm going to come back and do it on the back. Make sure you know what you're doing. Okay, Guided Practice 1. Let's simplify square root of 24. What factors go into the square root of 24? Well, I see the square root of 4, right, times 2, which gives me 8, times 3 is 24. So I can separate this into 3 square roots that are multiplied by each other. Square root of 4 times the square root of 2 times the square root of 3. Well, I know the square root of 4 is 2, but I also know the square root of 2 and the square root of 3 really can't be simplified any further. And so I'm going to recombine them and end up with 2 square root of 6. That's what you should have gotten for part A. Let's look at part B. Part B is the square root of 25x squared. Well, again, I can separate this into several factors. I have 25 times x squared. I know 25 is a perfect square and x squared is a perfect square. Square root of 25 times square root of x squared. In this situation, I know that square root of 25 is 5, square root of x squared is x, and so I've completely simplified this to 5x. Okay, let's move on to the next thing. Now, we're going to look at this in reverse. Example 1 said, how do we simplify a radical? But we can also go the other direction and multiply radicals. And so we're going to look at a few examples of that. Say I have the square root of 6 times the square root of 6. And if you're tempted to ignore this and say it's too simple, understand that this is going to help you solve a lot of problems, so pay close attention. When I multiply the square root of 6 times the square root of 6, I end up with a square root of 36. And therefore, if I take the square root of 36, I now have 6. What that means is it's a pretty useful tool, and we're going to use that in in day 2 of 11.2. When we want to get rid of a square root in the denominator, we were going to multiply it by the exact same square root, and then you'll see you're just going to get a regular number. So let's look at B of example 2. And in B, we have square root of 3, which has also an x in there, so the square root of 3x times 4 square root of x. All right, let's look at that carefully. Well, 4 is already outside the radical, so there's no need to do anything with that. We're just going to let that be. But the rest can be combined inside the radical. So we'll have 3, and then we have x squared. So now that we've multiplied these together, and we've ended up with 4 square root of 3x squared, we now look, can we simplify this? Well, we're going to do the same thing that we did above and find the factors. 4, and we have 3 times x squared. So 4 times the square root of 3 times the square root of x squared. As you can see, the square root of x squared is a perfect square, And so that's going to simplify to just x. And we're left with 4 times square root of 3 times x. And convention says that the x should go after the 4 and in front of the square root of 3. That's the proper way to write it. And so our answer is 4x square root of 3. Okay. Let's try another one. Let's look at the square root of 7xy squared times 3 square root of x. Just as we did the first time, our first step is we got to combine these two. So anything inside the radical is combined. So the 3's outside, we're just going to leave that outside because it's already outside the radicals. And everything that's in a radical can be combined in one larger radical. So the 7 stays as is, but we have an x here and an x here, and that combines to x squared, and we just keep the y squared here. Okay, we've combined everything, and our last step is going to be to simplify. So to simplify, the 3 remains out here. The 7 is as simplified as it can be. But then I can see, oh, can I take the square root of x squared and the square root of y squared? Or I can see that I can take an x out of here. I can take a y out of the y squared. Square root of y squared is y. And the only thing here that cannot be simplified is just the square root of x. I'm sorry, the square root of 7. So I am left with 3xy square root of 7. I mean, make that look just a tad neater. There we go. And we'll put it, there you go. Now that actually looks like a 7. All right. So I'm going to pause there, and I'm going to ask you to do number 2, guided practice number 2. And I'm going to stop this video, and I'm going to pick up guided practice number 2 as the first problem in the second video.